Hello friend, you are welcome back to this session B. Session B is a brief background on the things we want to do. First, we need to introduce you to the type of data available, the types of data available. Then we'll look at the difference between correlation and regression. Then we look at regression, as the two broad types of regression analysis we have. Then we look at regression analysis, two broad types of dependent and independent variable in the multiple regression model. Don't worry, we'll make it simple. Our method is just to help you become the best you can be in this program. So trust us. Now, we also look at regression analysis. The important principle in terms of the variables to include in your multiple regression and what not to include. Okay, how do you decide? Is it everything you just keep turning into your variable or into your model? There are things that should inform what the variables should be included in your model or otherwise. Okay, so these are things we want to quickly look at in this session. Now, the types of data. Basically, I want to show you like the four major types of data. The first one is cross-sectional data. Cross-sectional data is basically data collected at a given time. Data collected through survey at a particular time. For instance, somebody may want to throw up a questionnaire to women to find out whether they will be willing to participate in labor force at a certain time. Somebody may want to throw up a data to small and medium scale industries to find out how they are feeling facing the challenge of taxation, whether it's multiple taxation or otherwise. Somebody may want to throw up a survey to obtain information on effects of certain things, phenomena, certain situation on households. Okay, that thing, because you are collecting at a particular time, it is cross-sectional within that period. Now, a time series data is such a data that we collect at different points in time. And that's the focus of this training. For instance, you decide to collect an annual data. Every year, you are measuring the GDP of a country. Every year, you are measuring GDP, you are measuring exports, you are measuring imports, you are measuring inflation rate. And you collect it year by year by year by year. It becomes a time series because it's running at a regular interval, at a regular time. Time series can actually be also monthly. It can be weekly. It can be daily. It can be per hour. So, but the interval in question should be regular. So that's time series. And that is the focus of this training. In another package, we'll be able to look at how to collect cross-sectional data and how to analyze it. But we want to maintain focus here. Okay, now, pool data is such a time series data you collect, such a cross-sectional data you collect over time. You are looking at a cross-sectional data, for instance, you are collecting information on household poverty indices, and every year you collect from a certain number of households. Another year you collect from the same, from the same community, and you collect it year by year or monthly or weekly. That becomes a pool data. So it looks like a matrix sort of. You are looking at a particular set of variable, but you are collecting it over time. So that becomes a pool data. Let me give you a typical example. For instance, we decide that we get to your community, your village, and there are 500 households in your village. We decide that every month we come there, we will collect information from farmers, and we will collect from 50 farmers. So each time we come, any 50 farmer we see, any first 50 farmers we see or randomly, we collect information from them, and it represents that community that month. In January, in February we come out again. We see a group of 50 farmers randomly. We collect data from them. This information represents the farmers for that month. Another month we show up, we collect information that represents the farmer. So as we are collecting it from those farmers every month, it becomes a pool data. When we pull all of them, yeah, that's the name. When we pull all of them together, it becomes a pool. So cross-sectional data over time that is pulled together is pool data. Now, what is the difference between that pool data and panel data? Now, take example the same issue of coming to your village to collect data from farmers, and we have decided from the beginning that we will do our random selection, and we have selected the 50 we want to use for this study. So every month we come, we collect from the same households. Every month, January the same household, February the same household, March the same household. We collect from the same household over time, maybe for 12 months, for 24 months, for 36 months. It becomes a panel data because we are collecting at regular time from the same element. Look at the statement here. Cross is a cross-sectional data collected repeatedly at regular time using the same sample size and from the same element. But in pool data, it may not be the same. It may or it may not. But in panel, it must be from the same element, from the same person or source within a particular population. So you see the difference between pool and panel. Pool, anybody can represent a particular time, but in panel, it must be the same element. Okay? And that makes it very, very interesting. Okay, now, if this panel data or pool data is complete for the period of, for the period we are reviewing, period under review, if it's complete, no element is missing, no household is missing, it becomes a balanced panel data. If any household, one or two or more are missing from your set, it becomes unbalanced panel data, and it has implication on the type of analysis you can do with each of them. Now, what's the difference between correlation and regression? Unlike regression coefficient basically measures the strength of relationship between two variables. You are looking at the relationship between performance in mathematics and performance in English. And you do that kind of regression analysis to find out whether people who are doing very well in mathematics could be found to be doing very well in English. That's correlation. You are correlating these two variables. Now, but in regression analysis, you are not doing that kind of thing. You are rather trying to check whether people who are, whether income, for instance, like we started, whether income is affecting the way people are consuming. So it measures the effect of a variable or a set of variables for multiple cases, multiple regression on another variable. So that's the regression analysis. Correlation coefficient measures the strength of relationship, whereas regression analysis measures the effect or the impact of a variable, a set of variable on another variable. If we say that y and x are correlated, it simply means, it does not mean that a change in x causes a change in y. No, it doesn't mean that. It doesn't mean that anybody who fails English must fail mathematics. No, we're trying to check that strength. Rather, it simply means that there is an evidence or relationship between the two variables, and that the movement in one variable on the average relates to a large extent how the other variable is moving. Okay? So, but in regression, we were primarily interested in such a measurement that estimates or predicts the average value of one variable called the dependent variable. You want to predict the movement, the variation in consumption, that's the dependent variable now, on the basis of another variable which is fixed, called your income. So you say that consumption is a function of income. So that's the difference between regression and correlation. Okay? Now, coming to regression analysis, there are two broad types of regression analysis. And we have the simple regression and we have the multiple. Remember where we started and what we said we want to do. These are the two first things we want to do in our training: simple regression and multiple regression. Now, simple regression is a situation where you have one dependent variable. What do we mean by dependent variable? Look at this. You have GDP is a dependent variable here. And then export is an independent variable. This example here is saying GDP depends on what transaction happening around export of this country. So it is a situation where one dependent variable is and one independent variable are analyzed. And which one is dependent? The one we are trying to estimate, the one we are trying to predict, the one we are trying to ascertain how it is affected by variation in another one. Now, so if export is, for instance, doing very well, and this sign here turns to remain positive when we estimate it, it means that each time export is increasing, GDP will be increasing. But if we do this analysis and discover that the sign here has become negative, it means that when export is increasing, it will be reducing GDP. And please note this at this point, that when we build our model, in most cases, we use the sign plus in between the variables to estimate that there is a positive relationship, between the independent variable and the dependent variable. But somebody can decide to formulate a model that is built based on a priori expected sign, based on expected behavior of the variable. For instance, if we had inflation here, and the person is expecting unemployment, for instance, and the person is expecting that increase in unemployment will reduce GDP, somebody can decide on his own to put a minus there, indicating that the model is at its a priori expected form. But in most models you see your setup, you'll be seeing positives there. But that does not mean that the result must be positive. It's just like a no hypothesis. It's just like you are taking a position, but it's not a final position. So I hope you are clear about dependent and independent variable. Dependent variable is the subject of the formula, if you remember your basic mathematics. Have you forgotten? A is equal to B plus C. Which one is the subject of the formula? Is it not A? That A is what we refer to here as dependent variable. I'm sure you will not miss it anytime. Whereas the one that you are interacting on the other side, that is not the subject of the formula, is what we refer to here as independent variable. And in certain places, you could see them bearing different names. You could see this one bearing explained variable, explanatory variable, the dependent variable being explained variable, or the dependent variable being endogenous variable, whereas the independent variable becoming, be referred to as explanatory variable or exogenous variable, and so many other similar kind of name. Now let's get to multiple regression analysis. Basically, this has to do with one dependent variable, which is the explained variable, and two or more independent variables. So the key difference between simple and multiple is that in multiple, the independent variables are more than one, whereas in simple is only one. Okay, so the example in this case is where we have GDP as a function of export and import. And I'm sure you have not forgotten our beta 1. What it stands for, we call it intercept. It's trying to represent the position of GDP if export and import are 0. Okay, you may not expect GDP of that country to be 0 as well. So this value here represents what should be the position if all other things are 0. Okay, but the fact that we have included export and import makes this model a multiple regression. This multiple regression can have more variables attached to it. But we are trying to say earlier that we'll look at it briefly. You don't just keep adding variables because you want to do multiple variables. Anyone you are adding should be informed by certain things, and those things are very, very important. Okay, now let's look at the regression analysis, the two broad types of independent variable in multiple regression. This is our nomenclature at Markel Enterprise Training Center. You may not see it obviously in textbooks. So we classified these variables because of what we wanted to learn here. We classified the independent variables in multiple regression into two. The first batch we call it the core variables or the core variable. This core variable is directly related to the objective of your study. So whatever is the study you are doing, this core variable are those variables that answer your objective. Whether they behave well or they don't behave well, you can't remove them from the model. They must be there. Then auxiliary variables are those variables that are not directly related to your objective of your study, but you have supporting, but they have supporting values based on theories or previous studies. This also sometimes referred to as peripheral variables. These are variables that people based on theory have seen to play a role in that kind of model you are doing. So how do you determine what should be your core variable? The core variable are those ones that addresses your objective in the model, the objective of your study. If, for instance, this study is looking at the effect of export and import on GDP, the effect of export and import on GDP, the core variables will now be export and import, because we want to check whether export has an effect on GDP. We want to check whether import has effect on GDP. But the person doing this study has found reason to include exchange rates, probably because it has to do with international trade, and exchange rate plays key role in international trade. It could find theory to support it. And so based on theory or based on previous work, previous research studies, you cite them to say, based on so and so reasons, we have found reason to include exchange rate in this model. So we want to find how it plays out. And some other person can say that based on theory also or previous studies, we want to include FDI. FDI here means foreign direct investment. We want to include FDI in our model to see how it plays out. Now, the reason it's important to identify which is your core and which is your auxiliary variable is that in the course of this estimation, you may find out that some variables here may not fit into the model. For instance, if the exchange rate doesn't fit into this model, the person doing this research may as well eliminate it in the model and in the whole study. If it's eliminated, it's not affecting the objective because it's not a core variable. The same thing is applicable to FDI. If the FDI variable is not behaving well, when we say we'll show you when a variable is not behaving well, there are some variables we call nuisance variables. Nuisance variables. They will not be significant and they will not allow others to be significant. So what do? You drop them out. Even sometimes in our circle of friends, we have some people called nuisance variables. They don't want you to make progress and they are not making progress either. And for you to become better off, you may need to excuse yourself from that circle of friends. And that's the kind of thing that happens in model here. So if FDI is not behaving well, it's not fitting into this model, I'll show you how to know whether it's behaving well or not. So relax. We are here for you. And you soon become a guru of econometrics. Okay, so if it's not behaving well, we can find reason to eliminate it totally and use only exchange rate and the rest. But if for any reason export is not behaving well, because it's a question, is a variable that answers a question in our objective to check the impact of export on GDP, we cannot eliminate it. We will necessarily keep it in the model and interpret it the way we have seen it. Okay, if it is not significant, if it's not behaving well, it must be in the model. So your core variables cannot be removed because they are needed to achieve the objective of the study. But the auxiliary variables are actually helping your model, and when they are not behaving well, you can drop any or all of them. I hope that is clear enough now. No confusion. Thank you. I'm happy you are flowing. Okay, now the other thing we want you to note is that somebody can keep adding variables because you want to do multiple regression, and you so much add it that the independent variable becomes too large, that it becomes almost useless. Now there's this theory called the principle of parsimony. It simply says that the independent variable in the model should be as minimal as possible. So don't just begin to add a lot of variables because you feel like having plenty of them. When you add variable, it actually has advantage in your model. But when it becomes too much, it could make the whole analysis. Of course, it may affect your core variables if you are not able to differentiate what is core and what is auxiliary. So the theory or this principle is saying, for instance, if 2 or 3 independent variables are good enough to estimate our model, then why must you use more than that? Keep it as simple as possible. Okay, so that's the theory, and we're going to apply it at certain points in this training, and I'll call your mind back to it. So the next thing we're going to treat is the session C, and session C is basically the practical session. Okay, so always stop here and get back to you. Thank you.